Okay, hello class. Today is February 9th. It's the day after our last video had just gone up, in which I gave you this exercise 2 that you see here, as well as the problem set to do on your own. So it seems as though, at least from the very few that actually did get submitted, that some people were having trouble with this. Obviously, that's only a small subset because, again, not everybody did submit it during class yesterday. So I'm going to also say this right now as a reminder. Classwork we need to get done during the class time. I know that it's a little bit difficult, especially seeing as we are at home, but technically I cannot mark you as here unless you do that classwork during the time of class itself. But again, it seems as though we had a little bit of issues with exercise 2 and that problem set. So what I'm going to do right now is I'm going to go over this with us together. The first thing that we were working on I had you guys work on was exercise 2, which had 5 parts to it, none of which were too long, so it didn't really seem like much of a problem. The first question was to find a set of 4 integers such that their order and the order of their absolute values are the same. So I need to think for a second, well, what numbers are in the same order as their absolute value? Oh, that's going to be all of my positive numbers. And I need to look right here. This tells me integers, which means that they're going to need to be whole numbers. They're not going to include anything like fractions or decimals. These are counting numbers, including 0 and including my negative numbers. No fractions, no decimals in these first 4 numbers that it's asking for, and they need to be positive. So, the best thing to do if I want 4 integers that are positive is just to go 1, 2, 3, 4. And I know it's not the most creative answer. I could do something like 7, 18, 25, 72. I could find a set of 4 integers and not even put them in order like this. I could go like 500, 23, 18, and then 152 as well. As long as my 4 integers are all going to be positive numbers, because positive numbers have their order, and the order of their absolute values being the same. We're just going to stick with 1, 2, 3, 4, because these are the easiest numbers for us to work with. Part B asks us, hey, now find a set of 4 integers such that their order and the order of their absolute values are opposite to one another. So, we can remember back to what we had done yesterday in the video. The order of negative integers is the opposite of the order of their absolute values. So, if I want to get 4 integers here, they're all going to need to be negative integers. So, let's do exactly that and pick out the first 4 negative integers. We'll do -1, -2, -3, and -4. Again, I know they're not the most creative of answers, but they're the simplest, which is going to help us answer this question the easiest. Again, I could choose numbers like -64, -10,722,000, or something as simple as -6. But These are our first 4 negative integers, so they're going to be the easiest for us to work with. Part C is very similar to part A, except for instead of finding 4 integers, that the orders are the same, now we're going to be finding 4 non-integer rational numbers. So these are going to be the things like fractions and decimals. Specifically, since it says non-integer, I can't use whole numbers. I can't use counting numbers. But once again, we know it's going to need to be at the very least positive because the order and the order of their absolute values are the same. So I'm going to have to deal with some positive rational numbers here. And here's the good news. We can also pick really simple numbers like this and do something like 0.1, 0.2, 0.3, and 0.4. 1/10, 2/10, 3/10, and 4/10. And again, not the most creative choices, but they certainly fill our criteria. They're exactly what they're asking for here. And they're super easy for us to work with. Now for part D, it's going to be very similar. It's going to basically be a combination between parts B and C, where it's asking us find a set of 4 non-integer rational numbers such that their order and the order of their absolute values are opposite. So this opposite part tells us it has to be negative, and non-integer rational numbers, that tells us decimals and fractions. This time I'm going to use the fraction counterpart of these, negative. So negative 1/10, negative 2/10, negative 3/10, and negative 4/10. Again, still not the most creative, but it gets the job done. Part E asks us, hey, order all of your numbers from all 4 of these parts in the space below. We're going to order them from least to greatest. We're ordering all 16 of these numbers. Our numbers should all be different, and we're ordering them from least to greatest. Well, on my least side, those are going to be my negative numbers because negative numbers are always going to be less than positive numbers. And if I were to look at their absolute values, my absolute value for 1/10 is going to be my smallest, and my absolute value for negative 4 is going to be my largest. Now remember, however, that that's going to be the opposite when we're dealing with the actual numbers. So instead of my first number being negative 1/10, it's actually going to start at negative 4, then go this way, and then these numbers are all going to be further to the right. So we're going to start out with negative 4, negative 3, negative 2, and negative 1. And then we go to this group and we start with negative 4/10, negative 3/10 is closer to 0 than negative 4/10, negative 2/10 is even closer to 0, and negative 1/10 is really close to 0. On the other side, now we're dealing with our positive numbers, part numbers from C and from A. For this, these numbers down here are going to be closer to 0, so they're going to come before these numbers. So we're going to start with 0.1, 0.2, 2/10 is even further away, 0.3 is even further away, then 0.4 is even further, then 1 is 1 jump away, 2 is 2 jumps away, so we're going even further, and 3 jumps away, and then 4 jumps away. Just like that, we've ordered all 16 of our numbers from least, that being negative 4, to greatest, that being positive 4. We got a little smushed down at the end, but it's not really that big of a deal because we got all 16 numbers down. Now, if you used more creative numbers, which I'm assuming many of you decided to do, you still need to make sure that they are ordered correctly. Remember, the first number that you compare is your ones place, then you compare your tens place. And remember, negative numbers are always going to be less than positive numbers. Remember, for negative numbers, the greater the absolute value, the less the number actually is. Absolute value of negative 4 is 4. That's why it's all the way down here, because its absolute value is greater than all of our other negative numbers. So that was exercise 2. It really wasn't that much of a difficult question. Problem set. For the problem set, we had 2 questions. This is question number 1. Before I get into this, though, we should hopefully be at about the halfway point of the video. Technically don't know that yet. Don't leave as soon as this video is done. I need to explain to you what your assignment is for today. I'm not going to do that until the end of the video, so make sure that you stay until then, but I'll tell you then what it is. Problem set question number 1 says that Mika and Joel each have a set of 5 rational numbers. Although their sets are not the same, their sets of numbers have absolute values that are the same. Then it asks us to show an example of what Mika and Joel could have for their numbers. Give the sets in order and the absolute values in order. And then it gives us an enrichment extension, which tells us show an example where Mika and Joel both have positive and negative numbers. So what I'll do is I'll split this one right down the middle. The first one we'll do our sets without having to worry about our enrichment extension. And the second half, we'll worry about that enrichment extension. So for the first half, we need them to have completely different sets. If their sets are not the same, and they have nothing in common between those sets, that means that everything that's in Mika's set, Joel can't have any of those same numbers. And yet, the absolute values are the same. Well, let's say if I wanted to put in Mika's set, if I wanted to put the number 5 in Mika's set, if I wanted to put the number 5 in Mika's set, that means I need to worry about the absolute value of 5. And the absolute value of 5 is going to be 5. What other number is going to have an absolute value of 5? Well, there's only one other number that has an absolute value of 5, and that is going to be negative 5. The absolute value of negative 5 is going to equal 5. So that means that Joel needs to have negative 5 in his set. So basically, what I'm going to do is Mika's just going to have a bunch of positive numbers. And Joel's set, well, Joel is going to have the opposite of those positive numbers in his set, so that their sets have the exact same absolute values, but their sets are completely different. So, as opposed to writing out all the numbers and then putting them in order, let's write out, actually, let's just pick some numbers here. We're going to go with 12. We're going to go with 2. We're going to go with 6. And then we're going to go with 40. That's going to be Mika's set. And for Joel's set, what we need to do is we need to take all of Mika's numbers and take the opposite of them. So the opposite of 12 is negative 12. The opposite of 2 is negative 2. The opposite of 6 is negative 6. And the opposite of 40 is negative 40. Well, good news. Now we have both sets made. We can put them in order. I'll write M order in order to put Mika's in order. And we're going to do it from least to greatest. So my smallest number is going to be 2, then 5, then 6, 12, and 40. Now what we're going to do is we're going to do our absolute value order, ABS order. And here's the good news. Since these are all positive numbers, the order of my absolute value is going to be the exact same as Mika's order here. So it's going to be 2, 5, 6, 12, and 40. Lastly, we have Joel's order here. And Joel's order, I don't know why I wrote Joel's whole name out, but it's fine, is going to be the exact opposite order of the absolute values. So instead of 2, 5, 6, 12, 40, it's going to be negative 40, negative 12, negative 6, negative 5, and negative 2. Now, we've put all of them in order. Mika's are in order, the absolute values are in order, and Joel's are in order. But now, for the enrichment extension, it says, give us an example where Mika and Joel both have positive and negative numbers. In this first example, Mika had all of the positive ones and Joel had all of the negative ones. Well, if I want to make an example where they both have positive and negative, all I'm going to have to do is I'm going to have to exchange some of these numbers across the two of them. So Joel and Mika are going to swap the 12 and the negative 12, and they're going to swap the 6 and the negative 6. So now Mika is going to have 5, negative 12, 2, negative 6, and 40. And Joel is going to have negative 5, positive 12, negative 2, positive 6, and negative 40. Now, one of these three lists won't change at all in its order, and that is going to be the absolute value order, because the absolute values are still going to all be the same, 2, 5, 6, 12, and 40. But Mika's order and Joel's order are going to change because now Mika has negative numbers that need to go to the end of her list, and Joel has positive numbers that need to go all the way to the right of his list. So let's look at Mika's. Our smallest number, let's look at our negatives first. We have negative 12 and negative 6. It's going to be negative 12. And then negative 6 is our only last negative number. Now we have 2, 5, and 40 as our positives, and those were already ordered over here, 2, 5, and 40. So we can copy that exact order, 2, 5, and 40. For Joel, once again, most of his numbers were already ordered. The negative 40, the negative 5, and the negative 2 are all going to keep their same place. Negative 40, negative 5, and negative 2. And then the other two numbers, our positive numbers, are going to come out towards the right. Out of 12 and 6, 6 is the smaller number, and then 12 is the last. And with that, we've done both this half and the extension over here, still using the same numbers that we used before, just swapping their groups. So that was problem set question number 1. In addition to that problem set question, well, it's not done just yet. We still have one more question to go ahead and do, and that is going to be problem set question number 2. Problem set question number 2 seemed to be the problem set question that gave the most people the most problems, and that honestly makes sense. It's a little confusing. It says for each pair of rational numbers below, place each number in the Venn diagram based on how it compares to the other. So let's completely ignore everything other than question A over here. Part A gives us two numbers, -4 and -8. If I'm looking at the two of these, I ask myself, well, which one of these two numbers is the greater number? -4 or -8? Okay, -4 is the greater number. But does it also have the greater absolute value? Which one has the greater absolute value? -4 or -8? Well, -8 has the greater absolute value, so that means that -4 is the greater number, and it goes in here, and -8 has the greater absolute value, so it goes in here. No numbers are in these two categories yet. So that's A done, and we can move on to part B with our next two numbers, 4 and 8. Looking at 4 and 8, I ask myself, well, which one of these two is the greater number? 4 or 8? Okay. 8. Out of those two numbers, 8 is my greater number. So 8 is going to have to go in this green circle, but does it go in the in-between part? Which number has the greater absolute value? 4 or 8? Well, absolute value of 4 is 4. Absolute value of 8 is 8. 8's greater than 4 still, so 8's going to go in this middle part. If I get a number that goes in this middle part, the other number is going to have to go into none of the above, because it's not the greater number, and it doesn't have the greater absolute value, so it's none of the above. There's B done, and let's head on and start part C with 7 and -3. Looking at these two numbers, which one's the greater number? Well, 7. 7's greater than -3. So 7's at least going to be in this green circle. But does 7 have the greater absolute value? If it does, it's going to have to go in this intersection. Well, absolute value of 7 is 7. The absolute value of -3 is 3. 7's still greater than 3, though. So that means that 7's going into this part, and -3 is going to have to go into the none of the above pile. Up next, we've got -9 and 2, and hopefully we can see the pattern here. Out of the two of these, which one's the greater number? It's going to be 2, but 2 doesn't have the greater absolute value. -9 here is the number that has the greater absolute value. So -9 is going to go into this blue square. Square, it's a circle, it's an oval. So I'm going to put 2 in my greater number circle oval, and I'm going to put -9 in my greater absolute value oval. Up next, we have 6 and 1. And which one's the greater number? That's going to be 6. And 6 also has the greater absolute value. Absolute value of 6 is 6. Absolute value of 1 is 1. 6 is still greater than 1, so 6 is going to go in here. And 1 plops into my none of the above category. Our next one, F, deals with -5 and 5. Well, out of the two of those, 5 is going to be my greater number. But which one of them has the greater absolute value? Well, I hate to break it to you, that's technically a little bit of a trick question. They both have the exact same absolute value, so neither of their absolute values is greater. So 5 is my greater number. It's going to go into here. -5 doesn't have the greater absolute value, so it's not going to go into my oval. It's going to have to drop into my none of the above category. The last thing that we have is going to be G, where we have -2 and 0. For -2, 0, the greater number is going to be 0. It's further to the right on my number line. But for the absolute value of 0 is 0. It's literally the lowest absolute value I can have. So long as my other number wasn't 0, it was going to be greater. -2's absolute value is 2, which is greater than 0. So although 0 is my greater number, -2 has the greater absolute value. So your chart should hopefully, at the end of all of that, look a little something like this. Of course, I decided to be fancy and use different colors for each of them. You don't need to do anything like that unless you want to. So with that, I've successfully gone over last night's classwork. Well, last afternoon's classwork, which means that hopefully everyone should be able to get this done and turned in because the work has literally been done for you. It's on your screen. You can rewind and pause to where you need to in order to get your answers that you need. In addition, there's also an assignment for today. And I'm sure you're wondering to yourself, what is that assignment? I mean, there's no more math for us to do in this lesson. He hasn't taught us at all about the next lesson. Plus, he didn't even post next lesson onto Schoology yet. What could the assignment possibly be? Well, you're right. I haven't posted anything new onto Schoology other than this assignment that the video is linked with. Your assignment for today is honestly just an assignment to make sure that you've watched this video all the way to the end. If you watched this video all the way to the end, you'll be hearing this message that I'm saying right now. And this message that I'm saying right now is that your assignment is to just send me a picture of your favorite character. Doesn't matter what from, could be from a TV show, a video game, an anime, doesn't matter to me. Just send me a picture of your favorite character in general. You can even lie and send me a picture of somebody who's not your favorite character. If you absolutely hate Captain America for some reason and send me a picture of Captain America, I would have no way of knowing. Just send me a picture of your favorite character and I will know that you watched this video up until the end, and you will get full quote-unquote credit on the assignment. But with that, I hope that you all have yourselves a wonderful day, and I will see you guys tomorrow for our in-class, in-teams meeting. I will see you all. Farewell.